Now we can look to put the new 4x1 card into the back of our Odroid. So first of all, we will remove the existing M2 SSD. That's that one removed, and now we will insert the new card, which is a 4x1 card. Now we will carefully slot this in. That's it in. And first of all, we will use one of these screws to fasten this down to the back of the motherboard. And that is our card securely in. And next we can put our original SSD in as one of the slots. Let's take this out first of all. And we'll slot this one in this slot here. And screw this into position. Now, as you can see, we have room for 3 additional cards, and that's exactly what we're going to add. We have 3 of these. These are crucial 2TB PCIe 3 NVMe SSDs. Get these out of their blister packs. We'll slot these in to the remaining slots. It's the first one. There we go. We now have 4 SSDs in place. As you can see, this does increase the depth of our card at the bottom, so we'll need slightly larger standoffs in order for this to sit correctly. And we're going to worry about how we fit this into a case after we've got everything prepared. So our next task is to flash a new version of the BIOS, which is what we will do next, which will allow us to use all 4 of these SSDs, each of which will have one PCIe lane to itself. So in order to download this updated BIOS for our Odroid H4, we need to go on to the Hardkernel website. From here we can go on to the products pages, and from here we can select accessories. And we're interested in connectivity, and in here we can see the 2 boards. Today we're going to be looking at the 4x1 card. If we open that up, we can see the details of the card itself. This particular card is not compatible either with the H2 or H3 series. This is because the H4 series of Odroids has a larger motherboard, and this new card is set up to fit with that new board. Further down the page, we do have some stats compiled by Hardkernel themselves. This gives you a good comparison with what differences in speed can be got with either having the single NVMe drive in place at the back of the normal H4 boards, the 2-slot board and the 4-slot board. One thing we can see from this chart is that the fastest response of both read and write times you'll get from your Odroid is having the SD card in the M2 slot on its own. If we add the 2 splitter, you do get a reduced speed by not by much. And what we're going to be doing today is the 4-slot card. And while the speed is still further reduced, it's still faster than a standard SSD in one of the SATA slots. But as this particular Odroid has no SATA slots, we don't have a choice. So in order to get this 4-slot card working, we need to update the BIOS for our Odroid. So we need to go into the download page on their wiki to download the file. We'll find there is a section marked H4 BIOS Update. If we click on that, we'll find that these are the details for updating the Odroid H4's BIOS. You can tell which BIOS you have currently installed by having a look on the project version in here in the BIOS setup. And there are instructions for preparing the USB key drive for updating your BIOS. We need to format a USB drive using the FAT32 file system. And you will find the BIOS update tool on this link here. We get the list of the BIOSes available for the Odroid H4. So I'm going to download this one at the bottom, the 1.05. If we download this to our machine, and to ensure we get a solid download that is not corrupted, we can download the SHA-256 as well. If we have a look inside the zip file, we will see there are 3 bin files. These are the 3 BIOS files. The first file, up here at the top, is the one for the H4 itself. The second is if you're going to be using the 2-splitter card, having 2 M2 slots. And the final one will either let you use the Ethernet network expansion, giving you 4 additional Ethernet slots, or for today's video, which is the 4 M2 slots. So this is the one we will need to use. In order to check the checksum of the file that you have just downloaded, to ensure that the BIOS has not been corrupted, you can use this procedure, either for Windows or for Linux or for Mac OS. As I'm currently on a Windows machine, I can use this command here to point it towards the zip file I have downloaded. If we run this against the BIOS zip file we have downloaded, it will generate a SHA-256 number. You can then compare that against the SHA-256 zip file you have downloaded. If the numbers match, then the file is binary correct. Then we're ready to move on to the next stage, to prepare our USB drive as FAT32, unzip the file to that drive, and then prepare to update our BIOS on the Odroid. So we'll do that next. So power off the Odroid by pulling the plug out and inserting your USB drive. Then reinsert the plug and power on. And here we are now in the BIOS. And as you can see, the product version is ADLN H4 version 1. So if we now move to the Save and Exit menu, you will see at the bottom of this page will be an entry for the USB drive you have inserted. Select this and press Enter, which will start the boot up. When the screen starts to refresh, press Escape. You then need to type in the character for the removable hard disk, in this case FS0. This will take you to the FS0 prompt. Type in the letters ls, which will list the files on the USB drive. We next need to type the name of the NSH file to flash the BIOS. In this case, we want FBnet for the card that we have added. Once you press Enter, the flashing process will begin. This does take a little while, so we will speed through until the end of this process. And here we are, having successfully reflashed the BIOS. Remove the power from the Odroid, remove the USB and reconnect to power, and power up holding down the Del key to enter the BIOS setup. We can now see that the product version has been updated to version 1.05. If we then go to the Advanced section and select NVMe configuration, this should now show 4 NVMe SSDs, indicating that all is well. We can then go to the Save and Exit menu, save our changes and exit. As I had Windows already installed on one of the SSDs, it should now boot into Windows. It's worth noting that Windows will consider that a hardware modification has occurred, and you may need to reactivate Windows. Once in Windows, you need to run the Disk Management tool. Pressing the Windows key and the letter X gives you an easy menu to run this. This will show that you have 3 drives that need initialized. Clicking OK will allow you to then create the type of volume you wish to use for each of these drives. In this case, I'm just after a simple volume for each drive. Once this has been completed for each of the 3 drives, the configuration has been completed. And here we are, remote connected into our new Odroid number 10 machine. And as you can see, we have 4 drives, C, D, E and F drives. Each of these drives is 2 terabytes. So what we're going to do is we're going to run Crystal Diskmark on our drives. And we'll run it on the D drive first of all. And we'll speed through to the end just to see what values we're going to get. And there we have a very similar performance between each of these 2 drives. Some slight differences on some of the tests, but more or less in the same ballpark. So what we've successfully done today is we have added a 4 M2 slot card to our Odroid H4. This is the baseline model of the H4, which has no SATA ports. But adding this card has allowed us to add 3 additional M2 SSDs, each of which is 2 terabytes in size. The process for updating the BIOS to allow us to access these new drives has been fairly straightforward, and the instructions on the Hardkernel website are spot on. Hopefully you have found this video interesting, but that's it for today. Thank you for watching.